Hi, this is Grover with Blue Collar Codes, Quick and Dirty. This episode is summarizing prior episodes 6 to 11. If you wish to follow along with this file, you can find it in the GitHub repository, which is linked in the video summary. So we're going to be going over looping concepts, files, functions, control flow statements, a little bit into dynamic typing, and then the helper function help. So I'm going to start with the looping concepts here, create a list, and then I can iterate through them by object. So for x in L, print x. And what that does is just give me access to the objects at each iteration, but it doesn't give me access to the original list position if I wanted to alter it in place. If I want to do that, then you would use for x in range of length of L to gain access to all of the index positions available in list L. Now I can alter L, so L of x plus equals 1. Now L just altered from this list from 1 to 5 to 2 to 6. So those are the two ways you can use a for loop. Now with a while loop, if you wanted to go through a list in the same fashion, you're going to need to use a counter or a cursor value. Here I'm going to create x at 0, and then while x is less than the length of L, I'm going to increment. I will print that value, and then I need to increment the x so it'll step through the list. So those are the for loop and the while loop. Now I'm going to show you continue and break, just a way to filter results or filter or control the flow through a looping construct. So here you have, I'm going to just create another list. So for x in L2, I'm going to print x, and then for x in L, if x is even, I'm going to continue, else I'm going to print x. So what this did is it loops through the outer for loop in L2. So the first item would be 10 to be printed here, and then it enters another for loop where it needs to go through the whole list L and all of those values before it can then go to the next value in L2. So that's why you're seeing here 10, and then all of the values that are odd should be printed, and then it'll go back to 11, then the two odd values, and then 12 and the two odd values. That's how you can use continue to just skip the current iteration of the loop. So once it hits a continue, it'll just go back and start the next iteration of a loop. Break will just do a hard stop. So I'll show you break now. So for x in L2, it'll break when it hits the 12. So if x equals 12, break. Else, print x. And for x in L, print x. So what you have here now is that I made a for loop, a nested for loop that's just looping through each object in L2. But if that object were to equal 12, then it would break through the loop and just end it. And so that's what you have here. Using break just ended the loop so that it exited the outer loop and there was no more, it just continues on with any code statements underneath this for loop. Now if I had done it on the internal one, then what it would have done is just exited the internal loop and then gone back to the outer loop for the next iteration. So that was looping concepts. Now we'll go into files. So one note for opening a file is that it needs to be in the location of the file where you're running your code if you wanted to be able to find it locally. Otherwise, you're going to have to use a relative or absolute path. So here, I have outlined, a couple functions here to show you how you can accomplish opening a file. And basically here I had a file creation function that is going to take some content, and if there is no file name given, it's going to default and give the file name summary 6 to 10. And here it'll find, you pass in content that you want written to it, you pass in a file name if you want it to deviate from this, and then it'll go and use open in a context manager to use that file name with write, and then it'll write the content that I gave it into that file. So the one issue here is when you use the interactive prompt, and if you were trying to use the interactive prompt to open a file, it's not necessarily running this interactive prompt from the location where you have the files you want to open. You'd have to give it the absolute path. So let's see if I can do that now. So let's say I'm going to copy the path. I don't know why I just did that. Maybe you can't paste into the... Let's see. Oh no, it saved it. I don't know why it repeated all those lines. Apologies on that end. But it seems to have saved the path. So hopefully now I can open this file directly because I have the full path. So let's see if I can open it. So with open path read as f. So basically I'm using open here with the R mode, which is read, because I don't want to overwrite the contents of that file. So with open, then the path here, R as F. This is the context manager version. And then I am extracting the full string using the read method for files. And then I'm just going to print that entire string. And so that is accurate to what I have over here. And so that is an example of opening a file. Now you can use other modes, such as writing, but that will overwrite the contents of that file. And then you also have append and then reading and writing. And append basically will allow you to write to the end of a file without overwriting it. And then read and write will allow you to perform both a read and a simultaneous write function. So for creating functions themselves, let me first clear this out to give us more space. So in order to create a function, you're using a def statement. So def space and then any kind of name you would like to give it, say lister. And then you can have optional arguments. So if you wanted to run something that doesn't need any arguments, then you could create this, and then it would print, say, hello world, the iconic statement. So I just made that, right? Now I can call it, and it prints the hello world. So that's the basic syntax. You have the function header with the def keyword space, a lowercase name of a function, at least that's the way to do it in Python, and then parentheses there. And then you call it just by using the same name and putting parentheses after it. Now let's create a bit more of a complex one that will accept a few values. So you have def. First of all, I can delete this function. Can't delete it and call it at the same time. I can delete the name there now. So now if I try to call it up, it'll throw an error. So let me clear that out. So def lister A and B. So now what I can do is input two values, but you have to be aware of what the inputs are. I didn't do any kind of control statement, flow or conditional statements that would limit input. So right now you need to make sure that either to type check or to make sure that it would recognize that these are not the same type and then do something about that. Perhaps it will turn one into a string and then add them together or what have you. But just keep that in mind. And so to go a little bit deeper into functions, you have different types of arguments. And the arguments go in order of positional. Then you have keyword arguments. Then you have variable amount of arguments, var args, and then you have variable amount of keyword arguments. I'm not going to go in too much depth here over those, but it'll be something of note, and I'll definitely check on the episode that has the functions if you wish to know more about the different argument types. So I'll create I have already here created more complex functions here for you to review. Here I wanted to solve a problem by, say, I wanted to first create a definition or create a function that'll create random points for me. And so here I have it creating 1,000 random points, and this is the content that is then given, or my intention is to give this content created to this function as the content, and then either omit the file name or allow me to choose a different file name. And so it's going to write the contents of this function, what this returned, it's going to write it into this file. And then I wrote another function to retrieve that information. A lot of this is redundant, but it's just here to outline for you how you can retrieve information from a file, how you can write information to a file, and how you can use a function to do this. So if you wanted to write the same kind of contents to a file multiple times, instead of having to write all of this code out each time, you could just create a function that reduces your overall workload. And so basically, this sample problem here was just, I wanted to create a file of points, and then I wanted to check to see how many of them are parallel to each other. So the lines created by 2 points, how many of them out of this random 1,000 created points is going to be parallel. And so I calculate, I retrieve the data from the file here. I run it through the slope calculator. So it'll calculate all of the slopes. And then this actual calculate function is creating a default dict, a different type of a collection, where it's using the slope as the keyword, and then all the values are going to be the points themselves that correspond with the lines. And then I wanted to go over, or just show you how you can use the JSON module to write all of this information to a JSON file. And then lastly, I made it so that you can load that file and print from it. So that should definitely, if you review this at length, that should give you a lot of information as far as ways to write functions, as well as how to use control flow statements, which I will go over here briefly as well. But definitely spend some time going over this to see how the control flow statements are being used, and how looping is being used within these calculations, and what type of functions I'm creating to perform what kind of tasks, and then also understand how within my main function here I am calling all of those functions separately, and then all of it combined together creates the output, but I've segregated it out to different tasks. So I'm going to go over a bit here some more control flow statements for you, since I outlined a bit into files, opening files more, as well as how you can use functions. And one other note I'll make is that this is a way to outline typing or give your functions type information. So this is the format used. So you'd say variable name colon the type, and then if you want a default value, you set an equal, and then that'll be the default value. And all that means is that when you call this function, you don't need to put in a number here. It can be done automatic. You can just call this function, and it'll default to 1,000. But if you want to add a different number to it, then you can. And then what it's showing here is it's going to output a list of tuples that are going to contain integer pairs. And so all of this makes it easier when you're using your own functions down the line, because, for instance, it just shows up on these tooltips here. Notice how I can go over create file, and it actually is showing all of this stuff, giving you hints as to what it's using. So when you start creating larger programs and you have, say, hundreds of methods, do you want to have to go find the source code for that method in order to figure out what you were trying to do with that, or if it has the actual output and functionality you want? Or you can just hover over it, and then what you've written in here as far as this text here shows up, as well as all of the typing. So the content is a string, file name is a string with the default value, and then it returns none. So it's kind of good and helpful to put this stuff in there to help you down the line. Even though it is a non-typed language or a dynamic typed language, this still will help you out dramatically when you're creating larger scripts. So over here, let me go into the control flow statements, which is basically if, elif, and else. So let me create a few variables here to compare. So if A is greater than B or less than B, print yes. And then you can have, you can put an elif. It's not going to hit this now, so I'll just show you this now. But if you wanted a more complex if, elif, then statement, it's basically formatted in the same way. You're just stacking them. So if A is greater than B, print yes. Elif B is less than C, print no. So it was invalid syntax because it wasn't brought back to the initial line. Because I actually rarely put in if conditional or control flow statements into the interactive prompt. So let me see. Let me see if it's even possible. Okay, just hit exit or hit backspace. If A is greater than B, which is going to be false, then is B is less than C, print no. Okay. So as you can see, this was false, so it skipped this line of code, and then it went to check this. It found out that it was true, so then it printed no. Then if A is greater than B, pass. Elif B is greater than C, print no. And then lastly, you can put in an else, which is what will output by default when everything else is false. And so as you can see here, based on the values that I placed up here, this was false, and then this automatically just printed because it is the default value if all of these end up being false. And so you can continually add in elif, 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 elif as long as you would like. You can also nest them, but it's usually frowned upon to do too much nesting of conditional statements because it can get very confusing trying to determine what is actually taking place or what is true and what is false. So those were control flow statements, conditionals, and a little bit into dynamic typing. But dynamic typing just means that I can change A's value, the variable's value, on the fly. So it doesn't mean that I'm in other languages. What you end up doing is creating a variable name, and then you'll specify that it is an integer, and then it remains an integer, and it only is an integer. And if you try to use it with any methods or anything that is not an integer, then it'll error out. Where this isn't the case in Python, what it does is it stores the type information at the object level. So it knows that this A string in memory is a string, but it really is only referencing that A, the name, is referencing this A string, and it'll pull that up from memory when called, but it doesn't check that A is in a string. It'll pull that value first, and then what other method or function you're trying to perform on the string will check if it's a string or not. So dynamic typing just means you're not trying to hard type everything from the get-go. It ends up being a bit more flexible because you can create functions that are accepting any type of type, and then you're just controlling it on the attribute level. You're controlling what happens once the value is already received, and then using, say, try, except clauses to catch errors, or using control flow statements. So that was a brief touch on what dynamic typing is. It just means that your variable names aren't typed, it's the actual objects themselves. And what this means for code and more complex code down the line, I'll get into a more advanced Python topic to cover that. So lastly, I'm just going to go over the help function, which may or may not help you, but it's if you wanted to get additional information on the fly and you don't have the internet, you don't want to have to type into PyDocs and search for an answer, and you just need some quick help on, say, an object. You would just type in help and then that object, and then it just gives you what it is, what class it is, what type it is it iterable, and what the methods are for it. And yeah, so that is the summary of episodes 6 to 10. Again, I'm Grover with Blue Collar Codes. Thank you for joining, and join me next time for more Python basics.